Alright, in this video we'll make a simple UDP server that will run on a FPGA board so we can verify that the Ethernet connection from our PC to the board is properly working and we can send UDP packets to and from the board to the laptop. Alright, let's get started. So I'll make a section board side. So I'll import the libraries as I go. So instead of just importing everything so you can properly see what is needed, right? Or we always need the standard IO to print stuff, print errors and whatnot. Okay. All right. So to do UDP communication in C, we have to use the sys/socket library, right? So don't worry if this uh, libraries are not in. It says that it's not included, but don't worry, we'll be compiling this on WSL. So I'm on Windows because I'm lazy. All right. So to make a all right, so to make a UDP connection, we have to make what's called a socket. So socket is in networking is like a connection between two endpoints, right? So here the endpoints would be the laptop and the FPGA board. So to make a socket, we first need to create a socket file descriptor, sockfd. It's just an integer. So file descriptor, the sockfd or a file descriptor is what Unix uses to manage network connections. So it treats a network connection as a file essentially, right? So it uses, instead of like specifying like an entire location for the file, it gives a file descriptor. It's just an integer, and that integer is used on like a table to like find the actual connection and manage it. So it, the idea is like that. So now let's create the actual socket. So the socket function is used to create a socket, and for that we have to provide af underscore inet. So you have to give the family of address we are using and the like what kind of packet are we using and also the protocol. So the family af underscore inet specifies IPv4. So if you want to use IPv6, you use this, but we are using IPv4, so it's this. And for TCP, sorry, UDP, we have to use sock underscore dgram for datagram. And for the protocol, we enter 0 because we are using the default protocol, which is UDP. So uh, the if since we are using a datagram you over IPv4, the default structure is UDP, because UDP there's no setting up connections, no like additional protocol needed. You're just sending the datagram packets. So there's nothing else. So the default protocol is UDP, so 0 for default, yeah. So now to check if the socket is properly created, you have to check if the sockfd is positive. So excuse me if it's negative. So if it's less than 0, that means there's some kind of error, right? So okay, now since we can't create, so now we have to terminate the program. So for that we have to use exit, which is in standard lib. So this will terminate the program with a code of exit failure. This is a macro that's like used to signify that the program, you know, exiting with a failure. Okay, so if it's working properly, then it's all right. Okay, so now that we have made a socket, now we need to discuss how what are we expecting to accomplish with this program, right? So I'll quickly clarify that. So let me pull up Paint, and so this will be my laptop, and this will be my FPGA SoC, right? So there are two types of connections. One is the Ethernet. I'll make it like thick, so it's a high bandwidth, right? Ethernet, and also there's a serial connection for uh, connecting to the terminal of the uh, processor in the FPGA, right? So this is serial, right? So what I'm planning to do is terminal, right? Terminal. So what I'm planning to do is to run the program here, P server, and the laptop will send some kind of data, maybe a text or any kind of data, and the UDP server will receive it, it will read it, and it will print on the terminal. So the terminal you'll see maybe like through PuTTY, right? So you'll see that the text is received, and in addition it will send a acknowledgement back. It will send the data and it will print it, and then it will send an acknowledgement back. So that's what I'm hoping to do, right? So okay, so as you can see, the communication, it goes both ways, right? So the server will have a address, so the IP address of the Ethernet port interface, and it also will have a port number, right? So it will be listening on that port, and in because it has to send the acknowledgement back, it also has to like take note of the sender's IP address and the port. So we have to take both of those into account. So we have to know this address and also this address, right? We don't have to know this address, we have to set this address so we'll properly listen on the correct port and interface. All right, so let's get back to the program. So since we need the, okay, so I'll set this will be the client, right? My God, my spelling is hideous, but yeah. So this will be the client and this is the server. So we need the addresses of the client and the server. So first of all, I'm sorry I forgot, but we have to define the port that we'll be listening in. I'll just do it like this. Yeah, the port can be anything as long as it's not like a assigned port for like HTTP or none of those assigned ports. As long as it's like a random port, it's fine. But sometimes the, the, the program that won't be happening because the FPGA has a very bare bones OS, so not a lot of port allocation from the OS itself, right? I think so. Maybe it's fine. So we have to create two address objects, right? So struct sock address underscore in server address and client address. So sock address in is a struct that's used to store IP addresses, ports, and IP addresses and ports in a way such that so it's defined such that it's used to like the other functions in the socket library. It uses these objects to give like you know, provide the IP addresses, and instead of just typing like the strings of the IP addresses and ports, you provide these objects, more cohesive, right? So this will be the this will store the address of the laptop, and this will be we'll set this as the address of the server. All right. Now that we made the structures, now we have to set the server address and port number, right? So to do that, first we have to make sure that uh, this is cleaned up, right? So when we make this sock address objects are struct like things, uh, they might have garbage values in them. So we have to make sure to properly clean them. So to do that, we have to use the memset function. For that, we have to it belongs to the string library. So memset, the memset function, you have to provide the pointer to the block of memory that we plan to uh, clean. Clean under quotation marks. Yeah, you can do other stuff as well, but right now. So server address and then the specific value from which we are, populating the block of memory. So 0 and the size of the block of memory. So all right, so what would this do is we are providing the memset with the pointer to the block of memory. So in this case, the struct, and what do we want to populate the block of memory with? 0. So we're cleaning it up to setting it, removing all the garbage values and setting it to 0. And this is the size of the block. So it's the size of the address, the struct. All right. So the purpose we are doing this is like the sock address underscore in, it has some uh, padding fields. So those padding fields, if they are not like 0, it can cause some errors down the line. So we do that to make sure no errors happen. So now let's actually populate the struct. So the struct, sorry, the sock address underscore in struct has 4 fields: the scene family, the scene port, the scene address, and also uh, scene underscore 0. It's the scene underscore 0 part is just padding because this struct has to follow the structure of another struct. So yeah, so the most important are the scene underscore family, which we set it to, it's the address family. So as you can recall before, it's AF underscore inet. Okay, so also uh, the SYN address, which is the IP address for the interface. It's not like a normal uh, it's not a normal like a string of the IP address. It's an actual it's another struct. So so you have to you go inside to it again. Wait, let me explain that bit first. So this is the format. This is the format of the sock address underscore in. We have a short that signifies the sign underscore family, right? So this will be 2 bytes. I don't need comments there, but yeah. This specifies, that it's IPv4. And also we have a this is the port number, which is again 2 bytes. And also this is the actual IP address, the address of the interface that we'll be listening from. And this is also another struct of type in address. This is because, the programs, they handle these things in like this very specific way. And instead of like just giving a string, we just put another struct in there. Okay. This will be 4 bytes. And finally, there is a collection of padding sign underscore 0, which will be 8 bytes. So this has to be like it's recommended that it's populated with zeros. So now the actual, so now what about the in underscore address struct? So that will have this structure. So that's it. So the S address is the actual IP address, and as you can see, the S address is an unsigned long. So, but we know the IP addresses in like a string format, right? Like the 10.10.10.100, right? So, but how to convert it into unsigned long? We use the function inet eton, right? Or we can use the macro in address underscore any. So this macro is special that such that like it listens to the port, like it listens to, not listens to, my bad. So yeah, it takes packets that coming from any interface. So whether if you, let's say the device has Ethernet interface and a wireless interface, so it will accept any packet coming from all those interface, not any packet, but it will filter from the port as well. So that's there, but it will listen in through all the interfaces. All right. So now that we clarified the structure of the sock address underscore in, let's populate the server address. So the port we specified it before, it's 5005. So since the FPGA has uh, only the Ethernet connection to connect to, like, as a network interface, I think, yeah. So we can we can put like in address underscore any, and that would be completely fine. But to be, I like to be specific, it's a new experience, right? Okay, so to set the, I made a mistake before. You use inet pton presentation to network. It's not a ton. I don't know what I did there. So to set the S address, it's a 32-bit unsigned integer. There are uh, two ways other than the in address any, that macro that listen to all the interfaces. There are two ways. One way is to use the inet underscore address. So this will directly convert this IP address into the 32-bit long and return it. But this is no longer used, and the other method is inet pton, right? The one here. So we can use that. So to use that, we have to use like a specific way, and that's if inet underscore pton. So the inet pton is used to set not only IPv4 addresses but any other like IPv6. So you have to specify which family we are using because they differ on how the size of the data we need to store the actual address. So af underscore inet, we specify the family and the string form of the actual address, the human readable form, and the pointer to where we actually want to store the converted value. So in this case, it's at server underscore address dot syn address. I think it's this address as well. So now we set this function and it returns like a code, right? So if that like an error code, like a what process, I don't know, code. So if that code is less than 0, that means like some kind of error happened. So, and this error, it modifies the global variable error no error number error number error no, right? So you can it modifies the error no and it modifies the error no and puts a code in there. So that code can be used to like debug what the actual error is, and to access that code we use p error. So you use p error and just write something like error in while setting error while converting IP address. So when printing, it will print this string, and after that there'll be a colon and the like the translated error number, like the global variable error number. It's an error. It's an error code, but that code represents something, and p error will print what it represents after printing this colon and the actual error. So print the error and let's exit. Failure. All right. So this is how we set the all right. So with this, we have properly set up the server's listening interface and port number. So now we can use that to actually listen. Okay, so now that we made the uh, port number and interface that we'll be listening to, we have to actually bind that uh, this address into the socket that we made before. So the connection will be listening on that address and that port. We'll be binding it together. So to do that, we have to use the bind function from the sys/socket library we added before. So let's do that. So again, the similar to this function, the bind function will also return some like debug messages, status messages, right? So we have to use that to see if it properly binded or not. To do that, we have to uh, add the function in an if block. So to bind, we have the bind function and to specify the file descriptor for the socket. And next, we have to have a pointer to the server address, and we have to make sure that the pointer is of the type sock address, not sock address in. So this is a type sock address in. So if we have a pointer to this, if we just put it like this. So okay, wait, I'll just type it. Make sure to cast it into a constant. Right? So this will return a pointer to the struct sock address in, and we are casting it to the construct sock address pointer type because the bind function requires that. And next, the size of the block of memory, so size of the sock address server address struct that we are providing. And that's it. So now if the binding, if it returns an error code less than 0, that means there's a problem. Again, there'll be a problem and it will modify the global variable error number, and we'll print that with a bind failed. So since the bind failed, we have like no use for the socket. We can close the socket. And we'll exit. So if this if condition is not met, that means the socket is properly binded, and now we have properly set up the server, and we are now listening. Not listening, we can listen now, right? So let's print that out before starting up. Let's print that UDP server listening on address 10.10.10.100 dash, not dash, my bad, percentage d and port. Okay, now we have successfully binded the socket, and we have successfully created the socket with a proper address and port, and now we'll start listening. So for that we'll create a while one. All right, so for to perform the listening we have to use the function requi. Again, requi is from the socket.h, and to use requi we need some kind of array to store the incoming data. So for that we have to create a buffer. So let's do that. It's a good place to make the buffer here. Uh, what would be a good size? Actually, it's better to have the buffer size as a parameter. Uh, let's put 1024, 10 bits. All right. So, so at every new loop, it's better to clear up the buffer, right? Because we might the receiving data might not use the entire buffer, right? So if there are like garbage values and we have not overwritten the entire buffer, that means the garbage values might be considered as part of the received message. So that might, that's not what we want, right? So let's clear it up. So to uh, clear the buffer, use memset. So memset and the pointer to the chunk of memory, it's buffer, and hold on. Now you might be thinking, "Well, this is not a pointer, this is the name of the array." This is called this is a phenomenon called the C point array to pointer decay. Yeah, I think that's what it's called. You can look it up. So if I use an array like this in situations like this, C will automatically consider it as a pointer to this chunk of memory populated by the array. So no worries there, and we'll be clearing it to 0, and the size of the chunk of memory is buffer size. All right. So now that we cleared it, now we can listen from the port and add any incoming data to the buffer. To do that, we will be using the requi from function. So that works in a special way. It has some parameters, and if it receives a certain amount of data, it will return a number that's equal to the total number of bytes it has received, right? So if it's a positive value, that means it has received that amount of values, positive n, that means it received n number of bytes from listening, right? I'll use the requi from. So the requi from will return like an integer, and that if that integer is positive, that integer will represent the total number of bytes received. And if the integer is less than or equal to 0, that means there's some kind of problem. So the function, first we specify the socket that we are connecting, then the actual buffer that we'll be storing the data in. So this is a void pointer, so you can just keep pretty much any, it's a pointer to the chunk of memory, and we give specify it as the buffer, right? The buffer there, and the size of the data, that will be the maximum size of the storable space that we have provided. So it's actually buffer size -1. This is because the data coming from the packet, we are considering it as a string, right? So then we need to have a null terminator because all strings in C has that, but the incoming data from the packet, it doesn't have the null terminator. So we have to leave space in the buffer to add that null terminator. So that's why we are only giving buffer size -1 as the space for storing incoming packet data. And we have to add a flag called a message wait all. So this will uh, make sure that the requi from function is blocking. It will wait until something is received. It will not continue the code. It will like pause the execution of the code until a packet is received. Next, we have to provide a struct sock address underscore instruct so that the function can store the sender's identity. Now this is where this comes in handy. This is why exactly why we made it. So we have to give the address of the struct so that requi from can like analyze the packet. The packet has the source address and the source port number, and it will store that here so we can use it in the future. So it's to make sure to cast it into the, it's not const because the requi from will be modifying it. And also the length of the client address struct, but we pass it as a pointer because this value will also be modified by the function, because after adding the after the function adds the address and the port number, the size of the client address thing will change, right? So okay, so now we have to create another variable to we have to create another variable to store the size of the client address. So that will be, I think, let me check. Okay, yeah, the type is socklen underscore t. All right, and now we pass it here. And that's it. So we will be listening from that port and address now. And now when the program is executing, it will execute like this, and it will be stuck in this point until a packet is received or some kind of error occurs. So now let's check if n is greater than 0. So if it is greater than 0, that means we have received something. So let's, so now whatever we receive, we are considering it as a string, right? So now we have to add the null terminator. Okay, and now let's print whatever we received. So like verify that the client address struct and that part worked properly, we'll print the source address. Okay, so we'll print the address here. All right, so another thing is that the addresses and the port numbers, all of those things, they are in a very specific format, right? So the format that is supported by the device is not the format that is used in network communication. So the format supported by the device can vary from device to device, but it uses a common format for network communication. So we have to make sure we translate from the network format into the whatever the format that the device supports, right? And on that note, I have made a mistake here. So here it should be, here now we are specifying the address of the server, right? So this, it should be the port, it shouldn't be like this. So this is something that the format that the device supports. It might not be the format that the network communication supports, right? So to do that, we have to pass this through a function called htons port. Okay, so this will convert it from the device format into the network format. All right, so that's my bad. And now to convert it back from that format into like the device format or human readable format, we have to use the following functions. For the address, ento a, and for the port number, and for the actual data we receive, we just send put format of. All right, what the hell? All right, and that's it. So we have successfully received a packet, and will now send a acknowledgement. For that, we'll first make a acknowledgement string, since I will just send ACK. Since the sending message has to be a constant, let's make it a const jar. All right, now that we have made the message, let's send it. To send it, we use the send to function from socket.h. So send to, we have to specify the socket, and the message, and the size of the message, and another flag that's used to like this is to like skip like the lower level hardware verification. I kind of had to use it to like not get some errors. So if you know the exact reason for this flag, just let me know in the comments. So I'm not quite sure, but like adding this helped avoid some errors for me. MSG underscore confirm. And now the where to send it, right? The send to, we have specified the socket. And since this is a UDP, the socket has no information about the destination, so we have to provide that. So remember the client address struct that stores the uh, laptop's port and IP address. We'll use that. So for that, const struct sock address star and the pointer, so the address of client underscore address and the length of it. So here the length we are not passing it as a pointer because we won't be modifying it. The requi from we passed it as a pointer because after modifying this struct, its size will change and the requi from will automatically modify this length as well. Since we are not modifying anything in the send to function, we just send it as a variable. So again, one thing that you might notice is that since this is UDP, there's no way of knowing that if the thing, if it sent or not. So we'll just have to assume that it's sent and let's print that. And we'll just go back up this loop. So at some point this while loop will be broken. And if that happens, we'll close the socket. And we'll end the program. So yeah, that's pretty much it for the server program, and in the next video we'll compile this and try running it on the server. Actually, quickly, I am so sorry, but I have made an error. So the inet pton, so we specify the address family, the text form, the string form of the address, and for the pointer to the place where we want to actually modify the address, we only specify up to SYN address. We don't specify the what's inside that, right? So this is as far as we go. We don't go. Okay, I just made a mistake there. And so that's pretty much it. So this will be the simple UDP server. It will receive whatever is sent and it will print that on the terminal. On the terminal of the FPGA board, will be viewing it through PuTTY, and then it will send an acknowledgement back through the Ethernet connection to the laptop, and we'll see that on the laptop's PowerShell. All right. So that's it for now. Now let's The next video we'll try compiling it and also make a small program that will run on the laptop so we can send packets through the uh, Ethernet connection. All right, thank you. See you there.